Hey everybody, this is Larry. This is day 26 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. Let's see. Oh, no bonus points. And also to my to all my people out there who celebrate Happy Diwali. Hopefully, I don't know. Well, hopefully you're celebrating it. Hopefully you're having a happy one. Okay. Today's problem is continuous subarray sum. It's 523. So given an integer array nums and an integer k, return true if nums have a continuous subarray of at least two elements that sums a multiple k or false otherwise. Okay. What does that mean again? Okay. So you want in a subarray. Why is it continuous? I guess that whatever. Two elements that sum up the multiple of k or more. Okay, so the first thing that I would do is mod everything by k, because anything that's modded by k, it doesn't matter anymore. Meaning that that's the remainder, right? And then now it becomes. I think the tricky part is the one element one, maybe. I have to think about it a little bit, but otherwise it just becomes the thing of, okay, well, what is this? Why is my colors weird? Am I weird? Let me refresh real quick. That's it. Okay, the color is okay. Okay, so basically you're just saying like you have a plus pre plus dot 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 plus whatever is equal to some, some whatever 0 mod k, right? Kind of, I mean, the notation's a little bit off, but that's basically the idea. So basically, and you have, and the thing that you would think about is like having a prefix sum, right? So if you have a prefix sum, what does that look like? If you have a prefix sum, then, that is just, what am I doing? Right, so that means that you keep track of a sub 1 plus a sub 2, a sub 1 plus a sub 2 plus a sub 3, dot dot dot, right? So you have a plus 1 plus right? And then now, to get a subarray of size of at least 2, we're trying to find out, okay, for all possible prefixes, so this is the current sum, which is there a way that we can subtract some of these so that it goes to 0, right? And of course, if you want actually 0 under mod, then it's just that that this sum is equal to this sum, right? Because if you just do the math, like if it's this sum, okay, so let's just do a more general one. So you have something like this minus something like well, a sub I plus dot 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 plus a sub I, right? A sub I. Then if you subtract these two, then you would okay, maybe you want to do a minus 1, right? Something like this, maybe. So then now you subtract the top from the bottom, you get a sub I plus dot 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 plus a sub n, and if these two are equal, that means that this is also going to be equal to 0 mod k, right? Under mod. So that's basically the idea, and from that we can solve this problem, I believe. Yeah. Only thing that I might be, the only thing that you may actually have to be careful about is that the 6, for example, because this is k, and then this would match up. But as long as you as long as you're careful enough that you're like not taking the one that was right before, I think that should be okay. Yeah. Just taking a look really quickly. What is this? Oh, it's just sum every number in that one. Okay, fine. Yeah, so here, oops, we might skip ahead a little bit because so we have a set of things that we've already seen. So the running number is equal to 0, and then here I'm going to delete this. Here you have running, well, we always want to set dot add 0, or the running sum for the 0 element. And here we do running incremented by x modded by k, and then if this number is already in it, yeah, I mean, so if you can't do one element, you would say something like this, then we return true. But the problem is that, for example, running, or if x is exactly k, then obviously this is always going to be true, but you don't want one element, right? So basically here we can just delay a little bit, kind of almost like the Fibonacci thing. So yeah. So then now maybe we have a previous is equal to 0, maybe, yeah. And then here we go if, and then scene dot add previous, and then here I guess we don't need this, and then here previous is equal to running, maybe something like that. I think that delays it by one counting, and so let's give it a quick submit. This is going to be linear time, linear space. I'm not going to go over the, hopefully this is right first. I'm not going to go over the complexity. No, nice, 939 days. I'm not going to go over complexity that much. This is linear time because there's a for loop here, and linear space because of this set, and all of one here, and there's going to be all of n elements at the most. I hope the prefix sum explanation is good enough for you. That's all I have. But that's how I would visualize it, if you want to think about it that way. And at least two things a little bit tricky. I think one variation that you can play around with, I'm just trying to look at the inputs. The variation that you can play around with is, there's maybe some m where it's the size of at least m, right? In that case, you would do the same thing here with the previous, but maybe instead of a previous, you have a sliding window of things that pop out, either with a queue or some kind of an array type thing. So then you could kind of check the scene that way. So that's something that I would kind of, do it as a practice at home. Maybe I did give away the answer, but at least it's something that you can practice the implementation of even if you knew the answer. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.